This is problem 7-66 from section 7.1.4. Consider the system of equations y equals cosine of x and y equals -1. Is it possible to solve this system by substitution, by the elimination method, or how about by graphing? So let's start with solving by substitution. So substitution is when I replace something in the equation for something else, or this method may actually be called elimination. Not elimination, equal values, if you may have heard of that before. So since these things both equal y, I can set the other one equal to each other. But really, it's kind of a substitution as well. So cosine of x equals -1. So I'm setting my equations equal to each other, or replacing -1 with y. So if I solve this, I'm going to take the inverse of cosine of -1, and that will give me my x, or my theta, or my value. So I'm going to take here inverse cosine of -1, and I'm going to get what x equals. Okay, x is equal to 180 is what it's saying. So x equals 180 would be my solution. So what we want to think about is what we might do here more with when we get to graphing. We want to think, is that the only possible answer? So let's try to solve it by elimination now. So elimination method is I'm going to have my equations stacked up on top of each other, and I'm trying to eliminate a variable. Okay, so I have them stacked up on top like this. Now, you might know this to be a couple of different ways. So one way you could do this is to subtract everything, okay? Or if you multiply the second equation times -1 and then you add. So either way, you're going to get the same thing. Your y's are going to cancel out, so I have nothing on this side equals cosine of x minus -1 will become a +1. Okay? So now what we would do here, we want to get our x on one side, so I would probably subtract 1. So -1 equals cosine of x. And if we look back up, that is the exact equation we solved when we did substitution. We had this right here. So from there you would proceed doing these same things in red, just like we did substitution. So this green is the elimination method. I end up getting the same thing. I'll still get x equals 180 if I solve this. Okay? Now the third method they ask is to graph this. Now what I have in my graph right now, I typed in both equations, y equals -1 and y equals cosine of x. Now what you're going to have to do, if you graph this originally with the original window, you're not going to see anything. It's going to be cosine of x. That equation is really going to be at +1, and your y equals -1 will be where it is normally. So what we're going to do is I'm going to go into window, and I'm going to show you, I changed my window settings, the x values, to be -360, and the maximum for x to be +360. So that's going to be zoomed out really far in the horizontal direction, but if you don't do this, you won't really see what the graph looks like. We know what the cosine graph looks like. We've been doing that. It should be the curve kind of up and down. So now if I hit graph, I will see the correct thing. I have my blue line is the -1, and my red is the cosine. So whenever they cross, I can see that that is also my solution. So again, I'm really zoomed in here, but I have my window from -360 all the way on the left to +360 on the right. So I know halfway between the y-axis and the end is 180, right? 0 to 360, the middle is 180. So right in the middle of those, we see the red and the blue intersect. Same thing on the left side at -180. So I see it intersecting twice. Now, what I asked you before to think about was, is there more than one answer? So now we know by graphing, we have x equals 180. X could equal -180. So think about, if I continued my window on farther than just 360 degrees, what is going to happen? We have these repeating cycles. So I know cosine starts up here. It starts up here and goes down and back up and down and back up forever. Keeps going that. And I have y equals -1, which was down here. So I should have these things intersecting at +180 it's going to happen again, another cycle after that. So I know each cycle was worth 360 degrees. So that's kind of part B of this question. It says, list at least 5 possible solutions. So we know one solution is obviously 180. We got that several times. But so now I'm going to think about my cycle continuing. I know I have, if I take 180 and I add a cycle to it, which is 360 degrees, now I have a possible answer, 540 degrees. That's another solution. If I take that and add another cycle to that, 360. Okay. I'm going to have 900 be another possible solution. Okay? If I add another cycle to that, because 360 is my cycle, a whole rotation up and down, if I add 360 to that, I'm going to be at 1260. Okay? So all of these are possible solutions. So here's one, and we also had positive and negative 180. So there's our 5 solutions. So as every cycle, it repeats. If I go back to my little pretend graph up here, it's going to keep going. And it also goes in the negative direction. Right? So I had negative 180 was a spot right there where they should have intersected. But it's also, I could have had negative, I had negative 900 or negative 1260 could also be answers as well. So I have more than just 5 solutions. Part C says, consider the list of solutions you wrote in Part B as a sequence and write a rule to represent all possible solutions. Okay? So I'm talking about a sequence. Remember, in a sequence, its domain is limited. So my sequence normally looks like this. And I have some other things here. So my domain is limited. N has to be greater than or equal to 1. I don't have when I plotted points in the sequence, we didn't plot one at 0, the 0th term, right? That was never written down in our list. We always started after 1 and went by integers 1, 2, 3 up from there. So we're going to start at only like one cycle. So through the first cycle, my answer would be 180, right? My solution. Then the next one was going to be 540. The next one was going to be 900. So these are going to be the numbers in my sequence that I'm trying to make an equation for. So I know the change every time is 360 for every cycle. So that's what the N is representing, every cycle. This is number of cycles. So I only want to talk about in the positive direction of cycles. So before this 180 right here, if I had to go backwards, I'd subtract 360, so I'd have negative 180. So really, this is going to be the equation for my sequence. We're finding out whenever cosine equals negative 1. Here's the equation for my sequence. It's a arithmetic sequence. I'm constantly adding 360 every time, and my 0th term, if I went before the first cycle, would be at negative 180.